Hi guys. Okay, we're back for another teacher-led problem on incomplete dominant. So per usual, we are going to go ahead and grab a notebook and or a sheet of paper, and we are going to get started. So before we get started with the problem, we just want to think about what incomplete dominance is. And as referenced in the slide before this one, this is when two parents have a heterozygous genotype. They get together and create an offspring that has a third phenotype. So for example, if a red flower mates with a white flower, then the offspring could turn out to be a pink flower. And that's just showing you, again, neither allele is dominant. So with incomplete dominant, you're now making another look to the equation. I don't want you to confuse this with codominance, because codominance was more of a mixture, whereas incomplete dominance, you are creating a third phenotype or look. So that's why we have our red flower mating with our white flower to create a third look, which will be the pink flower. Because remember, that pink flower was not a genotype or phenotype given from the parents. All right, let's go ahead with the problem. So I'm going to skim over the problem. It's right in front of you, and we are going to begin. So in horses, hair color is incompletely dominant. And then the possibilities for hair color is listed. So on my paper and on your problem, we have dominant B for brown hair horses, recessive B for white haired horses. And then we have heterozygous. There it is again. It's different. So homozygous, as long as it's the same. And then heterozygous. But anyway, we have dominant B, recessive B for yellow. So again, it's not required, but I always write down the information that is given to me from the problem. And then per usual, we have our genotype and phenotype. This is just our reference, to get it in your head. And then down here, I have this circle because this problem is asking about genotype and phenotype. So anyway, we have our horse hair colors already down. And it says, let me get ready to write. It says a brown horse crosses with a white horse. So what we want to do first is we want to look at our key or our code, right? And we have brown. They said brown first, right? So that's dominant B. And again, I did not make that up. I took it from the problem, right? So we have dominant B. A brown horse is mated with a white horse, right? So we look at white, and then that would be recessive B. If we want to just go back real quick to see what is required of us from this problem, determine the genotypes and the phenotypes of the offspring, right? So again, we have a brown horse mated with a white horse, and it can also say cross. It's the same thing. So again, remember, a dominant will always come before a recessive. Think about the mountain lion or the baby rabbit. The mountain lion is stronger, right? So here, go here to here, here to here. Dominant B, recessive B. Dominant B, recessive B. Dominant B, recessive B. And I prefer you to say dominant and recessive versus big B, little b. So dominant B, recessive B. Dominant B, recessive B, right? So right away we have our offsprings, right? So we'll do genotype first. The problem wants to know what would be the genotype and the phenotype of our situation here, right? So we're going to look at genotype, and if we look back at our reference, that's the genetic makeup. It's represented by your alleles or your letters, right? So if we look here, lucky for you all, 100% would be dominant B, recessive B. I'll just say 100%. I could have did the 100% in the front of it, but it doesn't matter. So our genotype, 100% dominant B, recessive B. So that's your genotype, your genetic makeup. It's always represented in the letter form. Now we want to know phenotype is the look. What do our offspring look like? What happens when you put a brown horse with a white horse? And this is just for this problem. What would the offspring look like, right? So if we go back up to our key, our offspring are 100% yellow. And again, think about it. Incomplete dominance. We had a brown horse mate with a white horse, and what was created was yellow horses. So that's incomplete dominance. So neither parent is dominant over the other. It'll be a blend. And now we have yellow.